Okay, let us now go back to the first part and remember the main notions we have been introducing for models in sciences. A model in science, it has, of course, to be based on a proper set of definitions. Most of the definitions come from sources like WordNet or its Dictionary of Synonyms, from the Encyclopedia Britannica, from a lot of different sources. I was not putting here Wikipedia because of most of the notions in Wikipedia are a little bit too fussy to be used. And of course from papers we have been developing, or from papers especially Bernhard has been developing and Thalheim was using. The first notion is the adequacy. It means that a model is fully sufficient, suitable or fit for the use. Adequacy is one of the main properties we have. A model should be adequate and a model should be dependable. Adequacy includes, of course, some kind of analogy relation, some kind of focus and some kind of purposefulness of the model. We are using quite often the notion of assumption, and assumption is nothing else as a statement that is assumed to be true, or let's say taken for granted, and from which the conclusion can be drawn. We developed also a notion of the model, or a model of the model notion, based on this model house, let's say a metaphor, where we have a basement, and the basement is the lowest and fundamental part, and typically it is a part of the deep model. The cargo of any instrument is a general description, what the instrument contains. That means in this case we are using for the cargo something like the mission of the instrument, of course in usage scenarios, the determination of the instrument, the abstract declaration of the meaning of the instrument, and maybe also a narrative explanation of the identity. A mission of the model consists of the function that a model plays in different usage scenarios, and especially also of anti-functions or forbidden ones that the model does not, let's say, have. The determination contains our basic ideas, features, particularities and usage models of the given instrument. The meaning contains the main semantic and pragmatic statements about the model and describes what the model really contains. Furthermore, a model has an identity. It is maybe a five-faceted identity. That means in this case we have an actual or obvious identity, the communicated identity, the identity accepted in the community of practice, an ideal identity, and maybe also a desired identity the model has. Coherence characterizes somehow nicefulness of a model. That means it characterizes the state of cohering and sticking together somehow the logical statements, so that the model is maybe almost consistent. Common sense is one element of the fundament of our model house, and it exhibits native good judgments, so that those that are accepted in the community of practice and used there. Often models should be considered as consistent. Consistency means the firmness, density, resistance to movement or separation in the really constituent parts or particles. Consistency is often given based on a logical system. We explained already that it is not necessary to have such kind of a logical system. Conventions are also a part of our model house fundament. They are somehow regarded as normative examples, agreements or customs we are using. Corroboration is one of the essential properties of dependability and especially of justification. That means we have some kind of explanation that this model is really that one what we need. One thing we should not forget is that models are based on some kind of common thought and some kind of culture, and in general setting we consider culture as the attitudes, behavior, conventional conducts, codes, traditions, beliefs, values, costumes, thought styles, habits, the system comprising of accepted norms and values, goals, practices, and so on. The culture of modeling is highly dependent, highly developed in a perfect style if it has no flaws and it results in a very good quality. The demarcation is one of the essential properties to say what something is a model and what is not a model. That means with demarcation we somehow describe the model being and the non-being of a model. We can develop a number of criteria for such demarcations. We call something dependable, it is really worthy, and we can count on that. Dependability includes justification and sufficient quality. One of the main notions we are using here for our models is the model function, or we say a model functions in a scenario as an instrument. That means it must serve very well in this scenario. It performs as expected, and it can be used according to the purpose for which it has been developed and designed. It is based on methods and actions we have been applying. We distinguish in our reasoning system goals, purposes, and functions. Goals are nothing else as a triple consisting of a state of affairs that is currently given, a state of affairs that we desire, and of course of a community of practice that accepts this state of affairs that we desire as a common aim. An instrument, and this is one of the essential parts of this lecture course, is somehow tightly bound to a model. An instrument is a device that requires skill for proper use in a given scenario. That means we need to have the skills in order to achieve what we want. We can support our goals, purposes, and functions, and it can be somehow accomplished. Dependability consists of justification and sufficiency. A model is justified by providing an acceptable explanation, or let's say even a proof or some kind of legal reasons, with grounds, warrants, and arguments, and of course a confirmation that it qualifies something to be dependable model. Methodology is nothing else as a system of methods, rules, practices, procedures, and postulates employed and may be potentially followed by a discipline. It is based on an orderly and principled argument for those who work in some scenarios. We use here also a notion that is coming from mechanical engineering or even from art. A mould is nothing else as a distinctive form in which a model is made, constructed, shaped, and designed for a specific function that a model has in a scenario. Molds are widely used in mechanical engineering. A mold is nothing else as some kind of container, so that we can pour some liquid, and after a while we'll have a shape of a figure that we want to have. Molds are very common also in science. For instance, in mathematics, we use the mold of how to solve a differential equation, or a set of differential or a system of differential equations. We distinguish between notion, term and concept. Also, most people consider term, concept and notion as somehow synonyms, but I think we should really distinguish those. A notion is our intuition behind a description of something that we have been observing. That means in this case it is a mental apprehension, a sentiment, an opinion of whatever may be known. A notion is, for this reason, in reality a mental concept. It can be considered as being an individual conception of somebody, an impression of somebody known, experienced or imaged. Typically notions are based on some kind of thoughts and observed phenomena. Therefore, a notion is somehow an inclusive general concept. It is often based on beliefs a person or a group has. It might also include some kind of personal inclination. And notions are typically based on some kind of witnesses. And we consider here in our model approach positive and negative witnesses. Witnesses as anti-witnesses and witnesses as positive witnesses. One essential notion in our model notion is the notion of origin. What is really modeled? It is in this case the beginning of the modeling process, and of course the criterion in which case the model process was really successful. That means it is the source of a modeled existence and formation. It is of course also a subsequent modeling activity. A model is derived from an origin, a model represents this origin, and the origin is somehow the pre-image of the model if we consider modeling as mapping. One other essential notion in our grounding of the model house is a paradigm. Paradigms have been widely considered in Kuhn's statements about the science of science. We use here a very specific notion. A paradigm is an application-oriented and theoretical systematic arrangement and a generally accepted and believed perspective of a scientific school or a particular discipline at a given time, within which theories, laws, generalizations, and experience are performed in support of them. It is a part of a general conceptual framework, and for this reason we consider those as a very specific part of this grounding in our model of the model in our model house. One notion that is often taken a little bit more in a general form is the notion of a pattern. A pattern is nothing else as a profound, recurring and consolidated problem-solution pair. Of course, it should be considered in a given context where it is useful and where it will be probably useful to others. Of course, in a consistent or coherent at least format. Patterns can be generalized to stereotypes. Patterns are typically in programming also specialized to templates that are directly given somehow descriptions of some code framework or frame. Another essential part of our model house, of the grounding, is the postulate. It is a proposition that is accepted as to be true, or let's say at least acceptable. For this reason, postulates are somehow the kernel of deep models. They should be self-evident, they should be generally accepted. It should be also, let's say, somehow useful for later developing, let's say, axioms. So it's being distinguished from the axiom as being relevant to particular science or context. And we do not consider that a postulate must be universally true. It should be followed from other axioms rather than being an absolute assumption. In semiotics, we distinguish between syntax, semantics, and pragmatics. Pragmatics is often neglected in computer science. It is, however, very important in order to understand what we do with the model. Pragmatics is a branch of semiotics and linguistics that deals with the relation between science, or let's say also linguistic expressions, and their users, so that the user can somehow interpret what pragmatics means. In the Encyclopedia Britannica we have a very nice statement. Pragmatics is then the study of how both literal and non-literal aspects of communicated linguistic meanings are determined by principles that refer to physical or social context, broadly constructed in this case, in which language is used. Among these aspects are conversational, conventional implicators. Other aspects include metaphor and other tropes and speech acts. That means in this case pragmatics takes us back to the evaluation by the user, and in this case by the user of a model. We distinguish pragmatics from pragmatism. Often it is somehow considered to be a synonym relationship, but in reality it is not. Pragmatism is based on a practical approach to problems and affairs. The value, the added value especially, of a model is considered. So the meaning of conceptions is to be thought in their practical bearing, that the function of thought is to guide action, and that the truth is preeminently to be tested by the practical consequences of belief. That means in this case the main conception of pragmatism is really the added value. There are also other concepts we should consider, like efficiency, utility, and usefulness. And pragmatism can integrate some kind of ideal representations on quality characteristics. In our understanding, a profile of a model consists of a goal, a purpose, and a function. A profile can be given only by the goal, only by the purpose, only by the function, but at least one of them we should have. Of course, if we give all three, they should be somehow associatable with each other. The profile states what is the model for. A profile is such an outline what the model can somehow support, and of course it is also supplemented by the anti-profile that declares for what a model is not designed and should not be used. The purpose is one of the properties of the profile. The purpose is somehow the goal of a model, together with the means how we can use and handle the model, or how we can develop and utilize the model. That means it is also characterized by these methods, so that we can achieve the, let's say, desired state of affairs. A purpose presupposes thus the declaration of a goal, or includes the separation of goal. We shall later see that the function of the model is the most important property of the profile, but we should also distinguish what a model has really as an added value, and for this reason we should somehow declare goal, function, and also the purpose of a model. We embed our model as an instrument into a utilization or deployment scenario. That is nothing else than a series of events that is projected and expected to occur, especially any of several detailed plans or possibilities for solving a task. It is an outline or synopsis of a play with a model and of postulated sequences of potentially possible events. Semantics is one of the most overused terms in computer science, and maybe one of the most not really properly understood. Semantics is one of the three branches of semiotics. It is concerned with the study of meaning in natural and artificial languages. We thus distinguish a linguistic meaning, like we do in linguistics, and natural meaning, like we do as humans, a referential meaning between expressions and maybe words, an intentional meaning, that means defined in terms of beliefs or other mental states, and conceptual role meaning, so the model has a cognitive role, or a computational role, or an inferential role, the behavioralist meaning, so it behaves as it is designed, the meaning for verification, a possible world meaning based on a, let's say, potential or possible world, semantics in the Kripke style, and a formal meaning, like we do in logics and also in mathematics, and potentially also in theoretical computer science. Semantics is often defined on the basis of a rule system, but there is no need to have a rule system, especially for the case when you consider natural meaning of expressions. As already claimed, semiotics is the study of signs and sign-using behavior. So languages can be treated as a sign, let's say system, with signifiers and the signified. Concerns in semiotics are often separated in Ogden's semiotic triangle that shows how a language expression, let's say based on a sign or icon, symbols or indexes, is related to objects, that means to reference or the concepts in the case of Peirce's interpretation, and it represents with which meaning we are concerned. So for this reason, semiotics has three branches: syntax, semantics, and pragmatics. A spectrum is, in our understanding, nothing else as a broad range of related objects, values, or qualities, or ideas and activities. A spectrum typically combines a number of scenarios as a bundle, and spectra are in this case then a number or collection of spectrums. The syntax is defined as the arrangement of words in sentences, clauses, and phrases and the study of formation of sentences and the relationship of their component parts. For this reason, syntax is often based on constructors which have some restrictions for their application, and they declare in which way linguistic elements are somehow generated and constructed. One notion we should not forget when we talk about paradigms, when we talk about the grounding and the basis, is the concept of a thought community or a thought school that shares a common grounding which is somehow undisputable accepted. That means we have in a thought school or thought community a number of people that have somehow mutually to exchange ideas, to maintain intellectual interaction. So the school is in this case something like a scientific school, an engineering school, or maybe only a thought school. Typically a school develops a thought style. It means how people should reason within this school. A thought school has typically leaders, often called professionals, and followers or laymen. The leaders determine the public opinion and the understanding of the thought school. And the thought mood produces some kind of, let's say, fan behavior by people who are ready for an identical perception, activity style, and maybe for an identical appreciation and apprehension. Whenever we talk about a model as an instrument, we should also talk about usability. Usability is nothing else as a quality of being able to provide a good service relatively to the required function of the instrument in this case. And the usage of a model means in this case that the model is used as being deployable in a proper way, so that we can really use a model according to the functions the model has in the scenarios. The third U is the usefulness. It is the quality of being of practical use. So in this case it is almost close to usability and usage. And the three U's are bundled by utility. That is characterizing the state or quality of being useful. And one notion we are using for the concept definition, especially for our mental concepts that we call notions, is the concept of witness. We have positive witnesses and we have negative witnesses. A positive witness of a notion provides an attestation, an outline, an affirmation of a fact or an event. A negative witness allows us to delineate which things are not represented by a model, and for this reason we use negative witnesses to mark off boundaries of a notion. And witnesses allow us, in this case, to alert demarcation for a given notion. So this is now all what I have to state now about this kind of notions. I think you should have now an impression what kind of notions we can have in the third and fourth part of this lecture series. These are not all notions, but I think the main notions. Thank you for being with us, for listening to us.